Um, for everyone at home, used to be in the before times, and we could go out and go to keynotes and go to talks in person. Speaker or the announcer would announce you, and then you'd feel good because someone said your name to a lot of people, and you walk up on stage and you feel great about yourself. So without that, I'm in my office, I'm standing up, I'm all alone. It's kind of dark in here. I had to embellish something for myself. So, ladies and gentlemen, please let's introduce Bryan Liles. All right. So let's get started on this talk today. So this is interesting. I was an early user of Rails. I remember back in 2005, and I remember my first RailsConf 2006. That is, let me count. That's 15 years ago. It's older than one of my children. It's older than my house. It's older than my telco career. Hopefully, it's not older than too many of you, but still, this is good times. And you know what? I am glad to be back at RailsConf today to be able to talk about ideas. And that's what keynotes are for. So this will be a keynote. I'm not going to tell you how to do the next big Rails thing. Eileen was up there earlier. That's her space. I'm not going to tell you how to, just do the craziest thing possible. You know what? That's Aaron's space. And I'm not going to be the leader of this great community. That's David's space. But what I am going to do is do what I always do, be good old pragmatic Brian. And today we're going to talk about little ideas are the catalyst for big change. And any good talk, I think, starts with something that has nothing to do with the talk at all. And today, what I want to talk about is the mass energy equivalent. What? What are we talking about? Mass energy? What does that have to do with Rails new? Well, hold on. Give me a little bit of time. I'm actually going to share that with you. So for those of you who don't know what the mass energy equivalence mumbo jumbo is, perhaps you know what this is. You know that equation from that Austrian dude, E equals mc squared. And you know what? If I was in the room right now, I'd ask for a show of hands. Who knows what this actually means? I can go ask my 13-year-old daughter. She'll say E equals mc squared. What is E? Mc squared. What is M? Well, it's E divided by squared because she can do that math now. Oh, really? What is it? So I'm breaking it down for you right now. Energy equals the mass times the speed of light times the speed of light. Well, now it makes a little less sense. But really, what does this mean? It means energy equals the mass times the speed of light times the speed of light. And you're like, what is the speed of light? Well, this is an interesting fact about physics. So we call it the speed of light, approximately 300 kilometers per second or 300,000 kilometers per second, but that's really not what it is. It's the fastest speed that something can travel in our universe. And because photons are massless particles, they can travel at the speed. So we call it the speed of light. But really, why do we want to talk about it? Well, because of this simple equation here, what we're actually seeing is that you can create lots of energy from a tiny bit of matter, like a really small amount of matter. That's the whole thing. The idea that Einstein postulated is that energy and mass are related. And because they're related, and because we have that c squared, just a tiny little bit of mass can create a huge amount of energy. So this is just for those of us who didn't get what I was saying before. Sometimes in math and in physics and chemistry, we put things in equations to make them balance. Why does it work? Well, people smarter than me know. I just know that because the c squared is there, it means that the equation balances. So let's dive just a little further into this. So objects that are moving or reacting to something have energy we can take advantage of. This is simple stuff. This is things that we learn in elementary school. So what's an example of this? So we have a bicycle. You pedal on the bike, it goes forward. If your bike has multiple gears and you put it into a low gear whenever you're climbing up a hill, less effort, more output. But if you're going on straight flat ground, or you're going down a hill, or if you just have really strong legs, you put it in a high gear. So now every little bit you pedal gives you more output. That's that energy. And then for the car people, well, physics is happening inside of your engine. Every time you go out and drive, if you happen to drive, whenever you press on the gas pedal, a little spritz, you're actually putting a little bit of gas into the combustion chamber. The spark plug ignites it, the explosion happens, pushes the piston, and yada, yada, yada. The car moves forward or back. So physics. And the final example here is something like a light bulb. Now, with the light bulb, a little bit different. You apply electricity to this filament and it glows. And there's other types of lights as well, where you can apply a little bit of energy to an inert gas. So you get like neon, and freon, and argon, and the rest of the ions. Kind of neat. Where is it going? So today, I'm here to talk about sponges. And specifically, that something as simple as a sponge at rest has energy that is inherent to it. If we could actually extract, crazy world, if we could extract all the energy out of this sponge, we could power a whole bunch of devices. But unfortunately, we haven't hit that part of our evolution yet. So just know that in every single thing you can see and touch, there's energy in it. And then also, inside of stars, there's also energy being created inside of stars. So, if E of mc squared asserts that masses at rest have energy that is inherent to them, if we could somehow go into a star, press a hydrogen 2 and a hydrogen 3 atom together with all of our power, we would get a helium atom, a neutron, and energy. Very, very interesting. And finally, just because I wanted to be complete here, the third item here is because E equals mc squared is math, it's also possible to go the other way. We can take just raw energy and convert it to mass. So look around. Everything that you have created at some point in time, according if the Big Bang Theory was correct, was a point. 13 billion years ago, single point. It was infinitely compacted, had an infinite amount of energy in there. And now everything you can see and touch and smell and hear uh, was converted from energy. So you can go the other way as well. But back on track. This is RailsConf, not Physics 101, and I am not a great physics teacher. I just love to read about it. So what we're really going to talk about today is something that we've learned from physics, effort and results. And then what we're going to talk about is this concept that literally anything and everything can start with simple concepts. See where I'm going here? But let's not forget that physics and these crazy ideas of things that are infinitely small, infinitely large, have properties that we don't yet understand. And that alone, the not knowing, makes it fun to think about. So, back to the top of the top of the talk. Little ideas can have big consequences and effects. As we see from physics, E equals mc squared is a little idea with a huge effect. And in programming, and specifically with Rails, we can talk about some of those things too. So, little ideas can have big consequences, big effects, but little ideas are also easier to explain to others. It's very important. So, this means that little ideas, hear me out, can be a catalyst for a big change. So, before I move on, I would like to introduce myself at the beginning. I want to give you a reason to listen to me. Hopefully, I've intrigued you enough with my layman's knowledge of physics to keep you for the next few minutes while I go through this journey of explaining what I just talked about. So, who am I? I'm Bryan Liles. I'm a lonely principal engineer at a Silicon Valley company. Why do I say that? Well, you know what? I am lonely. I was the only Black senior staff engineer. I'm the only Black principal engineer out of 40. I'm lonely. And why do I come here today? Well, I want people to see that, you know what, you can look like me and still be and still do these things. You can look at like me and still like computers, cars, and culture, especially the hip hop. That's what I'm here to show. I am living testament to things can be different than they are right now. And then finally, um, I'm a huge hip hop person. They wouldn't let me play. I got either my sampler that's in the door behind me or some turntables, put them up here. We could have a good old time. But that's not where we are today. And finally, I'm at Bryan L on Twitter. These days, it's the calmer, um, nicer Brian. Follow if you want, or mute or block. There you go. So back to my talk. So what we're going to talk about here today, getting back into the talk, is this concept that you all might be familiar with, Rails. Have you ever just thought, just generally, what Rails brought to the table? And I do. I think about this all the time. Why was Rails such a pivotal moment in my life? Why was Rails this big idea? Why is Rails still this big idea? Well, one idea that comes to mind right now is this concept of simplicity. And getting into this conversation, I work with a lot of people who are sticklers for words. I grew up in the South. Uh, my command of the English language is basic. I know what you're saying, but I don't speak the Queen's English at all. So I wanted to talk about something today. I wanted to actually bring up this term simple, complicated, and complex, because I think that we conflate, especially those last two. So I wanted to clear those up before I get into this talk, because I'm going to use them quite a bit. So simple and complex. They for this talk, and actually probably in the real world, they actually stand for, or they actually talk about a number of components in a system. And a system could be big or it could be small. But simple components have our simple systems have less components, complex systems have more components. That's it. And then we have that other C word, complicated. And complicated talks about an amount of effort. And whatever you choose to measure that amount of effort in is up to you. But just understand that complicated and complex are not the same thing. So if we go back to this, if we think about simple systems, I have a Rails app where I've made no changes. That's a simple system. Or if I have a, let's say if we're going to go to Google and using like their TPU, their AI, their little AI computation image um, hardware pieces. That's simple because the API is actually not too is actually not too hard to grok. But on the flip side, the Rails app is way less complicated than the TPU. To understand the TPU fully, you probably need to have a PhD in something or else. So it is complicated while being simple, but you can also have things that are complicated and being complex. But we're not going to talk about those because we never want to be there. So moving on, now that we had that little English lesson. So first thing I want to talk about here today is this idea of convention over configuration. So what do we have to think about when we're creating a web application? You never do it. You type Rails new, or if you move to another language, you type whatever you need to type. But we don't quite think about that. So I actually wanted to go through some items here of things that you might think about. If you're using Rails, you might think about views and databases and requests and security, and then ... which could be authentication, authorization. You could think about other services you're interacting with, queues. You could think about the infrastructure that you're running on. Oh my gosh, that's a lot to think about. But specifically, I wanted to dive into a few items here that I think that we should be thinking about. So if my web framework had well-known locations for files, well, guess what I wouldn't have to do? I wouldn't have to hunt down where my views are. I would know where my database configuration or my app configuration is. And why is this important? Well, yesterday I was using Ansible to boot up some instances, and it was a whole new project. And I ran the Ansible command. I said, "Oh, I forgot. Oh, what's the directory structure for my Ansible setup?" They have one. It's actually very well documented, but there's not anything that allows you to set that up. you have to pretty much do it yourself. So you have to set up your site.yaml, your inventory files, all your tasks. Like, whew, that's a lot. So if my web framework had a good abstraction for databases, well, guess what I wouldn't have to think about? I wouldn't have to think about how to connect to my databases. I could supply some kind of authentication information, and that can differ from dev to whatever production environment I'm running in. And well, what if I had like an ORM? And I'm not having the ORM battle today. Active record has gotten many of us great jobs and allowed many of us to do great things. But sometimes that ORM, that active record pattern, has allowed us to do things that, if I'm doing simple CRUD, what's the difference? If you didn't have that, yeah, because you get it all done, yes, but it would be a lot more configuration. Well, what if my web framework had to modify a request or response in flight? An example of this, there's a couple. We could think about CORS. All right, we want to throw in CORS headers, or maybe we want to throw in change the content type if we didn't happen to do that. Or maybe we want to do things like authentication. Or maybe we want to do logging. So we have to get the request before it comes in, we can get the current time. And then we have to get the request when it's coming out. And so we can actually determine how long that duration was, what the response was, the size of it, and anything else we wanted, so we could actually print a log. Well, like I said, if you knew how to do all those things, you could definitely do all those things. But with Rails and specifically with Rack, you don't have to think about that anymore. You just talk about here, just throw it on the queue. And guess what? The framework takes it care of it for you. So one interesting thing that I've noticed in my decades, quarter century plus of being a computer person, is that developers love knobs and switches. There is nothing better for me being able to go in and tinker with the system to get it working like I want it to work. And think about it. You're thinking, that Bryan guy, he sounds like a cowboy. He's loose cannon. But think about it. Think about how many times in your head you said, oh, I'll just change this configuration item. Oh, well, I'll just add this field. Oh yeah, you love knobs and switches too. A good feeling slider or a knob that you can twist and turn, come on, nothing better than that. Something that developers don't like is that configuration tax. So like I was saying before, we love configuration. It's how we get things done just the way we like them. We can solve any problem with any amount of configuration. But every configuration does have a tax. At first, you know what? Taxes aren't bad. We pay for bridges and roads with them. And we just pay it and we move on. But sometimes taxes can become a burden, and that impacts productivity. Yeah, you might have heard of this term of technical debt. Well, this tax is a form of technical debt. When you have too many configuration items, it becomes a debt, which you have to pay off in the future if you want to be productive anymore. But we also have to understand that developers have a love, / hate relationship with complexity. Every configuration knob and switch can contribute to the complexity of, of your or complicatedness of your system. Well, in isolation, neither is bad, as long as they remain something like, if we're going to use big O notation, like O1, ON, or O log in, or even ON. But after a while, specific combinations, this knob, this switch, with these other 5 knobs become like an OM times N, or an ON squared, or even worse, like an ON bank. We don't want it to do this. We want to avoid that problem. So what do we do here? Well, I got an idea. Well, first, what we can do is we can invert this premise of configuration by introducing convention. For example, assume there's a good path for creating a web application. We assume that there's a database, JavaScript, forms, and multiple endpoints that may be served by multiple formats. You have a term for this in Rails land. It's called convention over configuration. So in my opinion, though, this is the basis for what makes Rails and modern frameworks that were influenced by Rails work. If you don't need to think about the foundation of a house, you can put more time in making the house livable. See that porch on the second floor? You can think about what kind of deck chair, what book you want to read there, instead of thinking about the structural integrity of the second floor. If you can rely on having something behave in a certain way, you can use those assumptions to your benefit. The same way that you get in your car or in your bike and you pedal and it just goes forward. You don't understand the chain. You don't have to understand what happens when you hit the gas pedal in your car. It just happens. So I want to talk about something that I've noticed for quite a while about this idea of convention over configuration. One thing I just want to stress is that it's not convention instead of configuration. No configuration is not great. We never want to be there. So just keep that in mind. It's convention over configuration. So, idea one. Now, with idea two, let's think about something else. How can we have the opposite of death by 1,000 paper cuts? And I'll dig into this a little bit more and build this up, so you can understand where I'm coming from. So, but before we get started, I wanted to ask you some questions. If I was in if we were in an auditorium or at a convention center right now, what I would say is, think about this out loud with me. So, why is building and shipping software difficult? Well, getting your development environment configured is definitely an impediment. Something that's pretty hard sometimes. Like, how do we get this thing installed? Or how do we get a new developer up and running? Or how do we get an existing developer up and running on this new project? Something, paper cut. Another idea. We want to ship software with the fewest bugs possible. Now, I want to say, we can't say ship software with no bugs because, I'm only human. And if I took all the bugs out, what are they going to pay me for next week? But seriously, we do want to think about shipping software with the fewest bugs possible. That is difficult. Paper cut. So also we want to think about this idea of how do we get software from a developer's workstation to a production environment? Many of companies have failed and maybe even ran out of money because they couldn't think of a good way from Bryan writing code to this running in some cloud or in some data center somewhere. Paper cut. And then we have this concept of handling production issues. What happens when an error happens in public and on the public side? What happens when you get the 500s or 502, 501? What happens when you do that? Well, you need to think about that. Paper cut. And then finally here, how do we scale with our users' need? I had this idea, I had 1,000 users. And then it comes to the point where I have 1,000 concurrent users. How do we scale from a little bit to a lot? Paper cut. And if you combine all these paper cuts together, what we see is that, we're getting close to our 1,000 paper cuts. And, if we were to brainstorm or workshop this a little bit, I'm sure we can come up with 9,000 or 995 more reasons. Sure, we could. So what I want to do is turn this on its head. How do we think about inverting this idea of a death by 1,000 paper cuts? Well, the first thing that I'm going to suggest is we think about how we reason about the world. And you can reason about big things and you can reason about little things. Now, when we reason about big things, we think about big concepts. We think about big systems. How does this fit in here? How does this system talk to this other set of systems? Or we could think about little things. And, these little things could be little services. And, there's a crisscross pattern all over the place. But I really am not talking about monoliths and microservices here. And I'm sure as I say this, that some of you are thinking, oh, monoliths are better than microservices, or microservices are better than monoliths. And what I'm saying is it doesn't really matter. What matters is that your team agrees to however you're going to proceed. Any of the other things, they're all silly. And you know what this argument is made for? This argument is made for so we can give conference talks, make blog posts, and we can grandstand on Twitter. Matter of fact, if I go on Twitter after this talk and say, microservices are better than monoliths, I will have 100 people telling me why I'm wrong. And then 15 saying that I'm actually preaching the good hymns from whatever deity they happen to worship. So let's think about big versus little things. And what I'm here to tell you here is big things potentially mean more. It means that there are fewer moving parts at the edges. And they might have a few more knobs and switches to adjust. And smaller things can be more focused, but there are more of them. So they probably lead to an equal amount of mess. So what's the same person to do? So I want you to lean in real close to your computer or your TV or whatever you're doing right now, and I'm going to give you the solution. So this is what we're going to do. So recently I learned about this term called money. And then I learned about cryptocurrencies. And I realized that if I had more money and more cryptocurrencies, I could buy more things like tennis shoes. Sure, I don't leave the house these days, but I like to look at them. So how can I help? Well, first, if you have, any money or any cryptocurrencies, shove them in your floppy drive. And if you don't have a floppy drive, put them in your CD-ROM coaster. Or, you know what, if you're current, up to date with everything, there. I take Venmo, Cash App, Apple Pay. I'm sure I could get Android, whatever. Yeah. But back to it. I really did get off track there. We're talking about paper cuts. And really what ends up happening in a lot of cases is it doesn't become death by 1,000 paper cuts. It comes death by 5 or 6 cardboard cuts. Now, if anyone here has had a cardboard cut, you know exactly what I'm talking about. But what I'm trying to make here is that these type of decisions are what actually leads to failure. How many paper cuts or cardboard cuts can you tolerate before you or your organization keel over? One thing that we don't do a good enough job with is problem solving. As a whole, we're horrible at problem solving. And I will hold everyone to task on that. So here's the thing. Someone's now asking, say, hey, Bryan, if problem solving is so hard, how come we've had so much progress in the last 40 years, especially in computing? And I said it was hard. I didn't say it was possible. We as a whole are not great problem solvers. We get there eventually, but at what cost? So why is this problem solving so hard? Well, where do we get it wrong when it comes to problem solving? Well, the first thing I'd like to suggest is we start with the wrong premise. Often, we set out to solve problems. When we set out to solve problems, we take our existing solutions and we try to pattern match them against our current problems. You know what? In a perfect case, this works because of the whatever diagram that we can draw, our problems fit inside of our solution. But what about when we're not in the perfect case? We need to think or rethink how we solve problems. So first things first, you need to identify the destination as best you can. So I remember reading this about Bezos from one of his shareholder letters. He would say that you never have 100% of the ultimate scenario laid out in front of you, but generally you can get to that 70% case. So what do you do with that 70% case? Well, you know what? The answer is quite a lot. So to get somewhere on purpose, we need to know where we want to end up. And we need to start with that, saying this is where we're going to end up. And I'm not saying you can't change it, but always move with purpose. So this strongly correlates with leading with purpose. So as humans, we are optimized or we're engineered to optimize anything we come across to something that feels more comfortable. We're lazy and we like good things. That's what the chemicals in our brain and our dinosaur brain do for us. So for some of you old timers, remember back when Java development was a thing, and then it moved into development. We took the paradigms that we learned in those old school architectures and tried to move them wholesale to the web. I remember right before I learned about Rails, I was doing struts and tapestry at the same time. Neither were enough to chase me with computing, but they didn't feel like web apps. And I'm not saying that they were bad, because at that point, back in 2005 and 2006, we didn't know what good was yet. Instead, I will just say that they were woefully inadequate and put us in weird places that didn't feel like the web. That's why when Rails came along, it was like a breath of fresh air. We still didn't know where we were going at that time, but it felt way closer to web development. So with that being said, I think it's prudent to evaluate our existing tools against our current problems. But what we need to understand is there are going to be some gaps. And force fitting those solutions that we already have to make them work for the problems in front of us may make even a larger mess than the one you started with. So the answer is to not continuously rewrite the world, but to create yourself a framework that knows the world is constantly evolving. And of course, I'm not talking about creating a new web framework or anything like that, but I'm talking about you need a method for evaluating problems in whatever your context is and finding and matching systems or solutions. And if you can't, well, that's the space for your next solution. So now we talked about this problem, we talked about this space that we need a destination, and our existing solutions may or may not work. So, how do we get to that destination? Well, there's a couple of ways that we can proceed. We can run, we can walk, we can skate, we can drive, we can fly. But this is also a place that we get hung up. So sometimes we start thinking about that vehicle for transportation or the means that will get us to the destination that we forget about the destination itself. There's a common, there's a common term that we like to use in our technical circles of bike shedding. It's when you put more thought into the color of the bike shed than the ability to store bikes away from the elements. And when you do this, you won't end up where you think. So how do we fix this? And I'm sure that we could actually talk about this all day. But really, how do we fix this? So let's think of some solutions for some common problems. We have requests that take 256 or 250 milliseconds to render. And this means that you need more workers to service your workloads. Well, really, do we need to do that? Is the problem actually in our request or things that our request talks to? Is the database slow or external services slow? Or maybe do we need more workers? This is what we need to do. We need to establish where we want to end up. We want to end up with this latency, whatever P99 latency we want to end up at. And we optimize for that. We don't want just say that, a quarter second to render a web request is slow. It is. But we need to think about the world in a different way. Another thing that we can think about is our application is too hard to move to production. Well, how do we solve this? Well, there's a long answer and a short answer. And I'm going to give you the short answer. At any point during your application's delivery to production, after it has been committed by a developer that has a human involved, automate that. That way, you can assume that it happens the same way every single time. So many teams get hung up because they say, well, I have this Jenkins pipeline number 47, and then I have to do the Jenkins pipeline number 95. Well, I said, if you know those, why aren't they just one or one calls the other? This is how you solve this problem. So another one would be, well, it's too hard to onboard people. Yeah, it is hard to onboard people. So when you're onboarding people, where's your documentation? What? Oh, you don't have anything written down of how you do day to day. How do you introduce somebody to a code base? What? They just go read the code. No. Part of taking care of a code base is making sure that it is documented, with whatever means. So it could be comments in there, not too many. It could be, your unit and your integration and whatever functional or smoke test that you have. But there should be some documentation that says, if you do these things, this is where you're going to end up. Once again, there we go. So I'm going to throw out this idea here that, we don't fix all the problems. So we listen for the screams and the pains so we know where they are, but we don't have to act each and every time. We should be able to evaluate these to understand which ones are important and which ones aren't. So these two little ideas, convention over configuration and the ability to avoid deadly paper cuts, are two small ideas that can grow into huge gains for your development team, your personal projects, or whatever. And this is how I'm trying to get people to think. Think in the small, and then think how you can make whatever you do in the small multiply to become something bigger. Don't come in, with a bear hug and try to take care of everything. No, small ideas. E equals MC squared. So in the next section, what I want to talk about is success. And the reasons I really like to think about success and what does it taste like? What does it smell like? What does it feel like? Is it sustainable? Is it available for everyone? And one of the reasons is because I can't go anywhere. So I have to pretend that, I work and I can eat every day and things are great, but I don't go anywhere. So success used to feel like, oh, after a hard year, we would go to a beach in a foreign country. That's not a smart thing to do right now. So I can only dream about it. So come on with my dream with me. What I want to talk about here is I just want to ask you some personal questions. Think about this amongst yourselves, and just think about the answers to these questions. Is success having all the money you'll ever need? No, no. In my opinion, it's not, and there's a reason why. And you'll see it on the next slide. A success, being able to live life on your terms. Well, yes, that is it. And what's the difference between having the money and living your life? Well, having the money is a vehicle. With the money, I can buy vehicles, I can buy vacations. But you know what I really want? I really wanted that vehicle and I really wanted that vacation. So being able to live life on my own terms, that's success. If you're thinking about the first thing, you're thinking about the journey. Focus on the destination. So along that lines, you'll see where I'm going here. Should everyone succeed? No, no, no. There's a lot of bad people out there who don't deserve to succeed. There's people who don't want to put in the work, and they don't deserve to succeed either. But should everyone have the opportunity to succeed? Well, of course. If you want to come and give your best self, you should have the opportunity to succeed. No one should be able to take that from you. So, what does success look like in the tech world? Well, the real answer is if I knew, like I knew, I wouldn't be here right now. I'd be off on my private island living life on my terms. Or maybe I'm wrong. Maybe I don't know that. Maybe success has led me to this point right here and right now, talking to my cameras in my office, hoping someone is listening. Maybe success is sharing what I've learned so others can build bigger and better things based on my personal successes and failures. And moving on, I would like to share a couple items that I think that might contribute to success. So, controversial point is thinking about success. Make your ideas simple enough to copy. What? Are you serious? Well, here, I will die on this hill. And this is probably is an unpopular um, idea. The best thing that Rails ever did was made its ideas easy to copy. If we look at the industry pre and post Rails, what we'll notice is that post Rails, things look a little bit different, but the same all at once. What do you mean, Brian? Well, think about this. This is a great thing. And really, if you understand how technology moves, nothing moves along alone in our tech industry. We can have good ideas which are identified, and those good ideas will be copied and extended and made available using different languages. Like you can't take advantage of Ruby on Rails if you're using PHP. Think about other ideas like Sinatra, and Caravelle, and Spring Boot, and Django, and Grails, and Express, and Gin. You know, I only thought about this for a second now. Now, if I squint and I think about these things, you know what? They all look like, if you're familiar with Ruby on Rails, well, I kind of get this. And this is true not just in this web development ecosystem. My day to day, I don't actually get to touch Rails much at all, but I work in telco and we do a lot of Kubernetes. And Kubernetes is the current juggernaut. A little shout out is that it's the KubeCon slash Cloud Native Con is the largest open source conference in the world. I used to run that. Amazing. But if you look at Kubernetes real close, you can see that some of the lessons that we learned from OpenStack and from Mesos, RIP rate Mesos, are evident in there as well. So when an idea is easy to copy, others will embrace it. And if the timing is right, guess what? Then we can see a yin-yang effect that increases the benefits for all users of all the technologies. And if we could look over the years, if we go from like Rails before 1.0, and then we got 1 and 2 and 3 and 4. And then we see some of the changes where the industry had applied some back pressure back to Rails, and Rails got better. And what I'm seeing now is the yin and the yang, and things are going back and forth. And that's great. Understand this. Just because you build it, people won't come and use it. This is not a movie. This is not Field of Dreams. The ideas that are copied are these simple ones, E equals MC squared. Those are easy to copy. And those will be the good ideas that we see moving forwards. The ones with the lowest mental overhead and the ones with the biggest bang for the buck will be implemented again and again for our benefit. So the next idea that I want to think about here is keeping our eye on the future. And just here, I like this picture. I don't know why. It's the Gulf of Mexico, and it's just very nice. The world is not stagnant. So understand that this. The act of writing an application is not enough. Just because you wrote it doesn't mean anything out of the context of when you wrote it. The world will move. So you need to move. And we need to think about what that means, whether you move technologies or you upgrade your current technology. You need to understand that just because you wrote an app, it's going to become stagnant pretty quickly. And this next item here is we also need to have some guardrails for that. We can't just move forward constantly and throw new features in. And if we do this, we'll get a mess and we'll get things that are not supported and things that don't work well. So we need to understand it's just enough tech. Just enough. How much tech do you put in there? Just enough. And I read through Twitter sometimes and I see someone who will say, you know what, I've been in tech for 20 years. And when I was young, what I would do is we would use all the fancy stuff. And I'm thinking, it's about like 2000, it's before 9/11. Or, what was hot then? Mandrake Linux? Okay, all right. And I would use all these things. And then when I got older, what I would do is I realized I would just use old stuff. You know what? If you're that person, I don't want to work with you. Because here's the thing, there's old good ideas and there's new good ideas. And we need to learn how to embrace that. And your time in tech should have taught you, those ideas of what's good and what could potentially be bad. And then realizing that you're not smart enough to know any of this and consider that everything could potentially be bad. So what's your exit? How did you exit from this? I don't know. So you've been in tech for 20 years. I've been in tech for 26 years. My 6 years makes me more senior to you because that's how it works, right? So I want to end here. Nope. When I say end, this is going to be like a black church. So when I say I'm ending, give me a few more minutes here. I want to throw some other random thoughts because it's not every day, and especially over the last year, that I get to share what's on my mind. And so there's a few items that I just want to throw out here, try some out. It's like, we're at the improv, some new material. This first idea is how do you justify your abstractions? And this is another item that I see on social media where people are like, well, I don't like abstractions. I'm like, what? They're like, no, abstractions are the worst. We shouldn't have abstractions. I'm like, word? And they're like, no abstractions. And I'm like, so do you or does someone else put bits in your CPU so you can actually compute? Who's creating those AND gates and those OR gates or those exclusive OR gates? Is it you or someone else? And they're like, Bryan, you don't understand. So I said, you like keyboards, right? Are you over there hitting the electrical signals to send items over your USB bus so your computer can compute? No, Bryan, you don't understand. Oh, I don't get it. Oh, you just don't like web browsers because, being able to have an abstraction to view HTTP in a graphical way is too much for you. Is that what you're saying? No, Bryan, you don't get it. Oh, I get it. You don't like abstractions that you didn't create. And this is like a little item for me, it's one of my little points, one of the other hills that I would like to die on. You know what? How do you justify your abstractions? Well, when they're good or they serve the purpose and they're well tested. Well, when do you justify them? As long as they need to be justified. And if we learn better lessons, we move on. But we don't pull off or curse abstractions just for the sake of abstractions because guess what? Everything's an abstraction. Even in the physical world, when you press the gas on your car, it's not the Flintstones. You are not moving it with your feet. You don't even know. Matter of fact, there is no mechanical, if it's a modern car, there's no mechanical bits between your accelerator and your engine anyways. So whatever, it's an abstraction. So what about SRE and DevOps? Well, what about them? The reason I like to bring this up is because I think that everyone should know a little bit about where your application goes when it goes to the Git repository. And I'm not telling you that you need to be an expert on SRE and DevOps and all these things, but I think you need to understand that practice because it is tangential to what you do day to day. So I'm not saying be an expert. I'm saying just understand what goes on. I love the car analogy. You understand that somewhere your car uses oil. If it doesn't have oil, if it's a combustion engine, bad things will happen. And pretty much if you're driving it, you can check the oil. But what happens? Where does it go? Well, that's not important. So know the level of being able to check your oil. That's it. And my final item here, wow, is this concept of software development should be equitable. And I just want to say this. So we come from many different backgrounds through all kinds of paths. We don't have a look, a style, or anything else. We're simply people trying to get ahead like everyone else. So what I'm saying here is there should, if I go to Google and I search for web developer and I see, someone and I search again and it's just the same looking person, you know what? That's not true. Software developers, you know who you are? Anyone who sits down and develops software. That is the requirement. And we should make, and those of us with privilege, with whatever, should extend whatever privilege we have to people who are trying to come behind us. But guess what? If you're on your game, they're not going to take your job. You're going to make the way so they can have a better future. We're not all out growing our own corn right now. We go to the grocery stores. You know why? Because we move past that and we realize that we don't need to do that. And I know there's a lot of horrible things about in the United States about where our food comes from and our immigration, but understand we want to make that equitable too. So what can we do as a group? Well, we just want to improve as a group. We want to know what failure looks like. We want to know when we need to pivot. Because that's actually the senior developer. That's a trick. Knowing when failure is inevitable or imminent and knowing when to move somewhere else. Because guess what? We fail just like you. We look at Stack Overflow just like you. I Google all the time because you know what? Nobody has time to remember all this stuff. But I know how to find it quicker than you do, probably. So what can we do? We can practice more. We can share what we've learned. I want to see one of you all in future years coming up here and say, hey, you know what? Bryan said something that made me think about this. And then I want you to realize this. We are all on the earth. No one who is not on the earth. Everyone that ever has been on the earth. We breathe the same air. We breathe, we when you cut, we all bleed. When we die, we all go nowhere. We are the same. So realize that since we are going through this journey all together, then guess what? We are all the same. So how do I really wrap up? Now the benediction is over at church. So I just want to say this. E equals MC squared. Little changes can have big effects. And we should constantly be thinking about those successes, about success and what success looks like. And not because we want to be better than anyone else. We just be thinking about it so we can constantly move in that direction. And I want you to leave here today, and this is it, and think about how you can make someone's life better. And then finally, wow, see y'all later.